In this video, we're going to find out how to find missing sides in a 45-45 special right triangle, also known as a isosceles right triangle, because the two legs are congruent, and the hypotenuse can be found by simply multiplying one of the legs by square root 2. We found out this pattern when we did the notes discovery problem, where we did a couple examples using Pythagorean theorem, and noticed that the hypotenuses in each of the isosceles right triangles were a multiple of square root 2 of the legs. So if you're going to find a hypotenuse given a leg, you're simply going to multiply by square root 2. And that's if you're going from leg to hypotenuse. To reverse direction, just do the inverse operation. I'm going from hypotenuse to leg. So let's change this up. Hypotenuse to leg. You're going to do the inverse of multiplication. You're going to divide by square root 2. So to go to the reverse direction, do the inverse operation instead of multiplication. You're going to divide, but by the same number, square root 2. Now these two operations will sometimes involve rationalizing denominators because you will be dividing by a radical. Sometimes it'll involve multiplying two radicals together depending on what kind of side lengths are for multiplication. Just depends on the problem that you're given. But it's very important to know that when you go from leg to hypotenuse, it's multiplication by square root 2, and hypotenuse to leg is you're going to divide by square root 2, no matter what your leg or hypotenuse numbers are. So in an example like number 1 here, they give you one of the legs, and they ask you to find the other leg and the hypotenuse. If they give you one of the legs, the other leg will always be exactly the same because it's isosceles. So it should take no time at all to answer for the other leg, because these two will always be exactly the same because these two angles are exactly the same, making it isosceles. The next part, though, you have to go from leg to hypotenuse. And if you recall from the diagram up here, leg to hypotenuse, you're going to multiply by square root 2. So we're going to take 3 and multiply by square root 2. And because square root 2 can't be simplified anymore, this number itself is going to stay 3 root 2. So we found the leg, and we found the hypotenuse. In a problem like this where you have a number with no radical, it's pretty simple and only takes about 10 seconds to do. The math doesn't change for these problems, but some of the rationalizing and multiplying radicals together takes a little bit more time. But the math itself, multiplication or division, does not change. Let's go to example number 2. Here they give you a hypotenuse and they ask for the two legs. Just a heads up, once you find one of the legs, the other leg's exactly the same. So you don't need to do double the work here. So just do one set of operations and then use that same length for x for y or vice versa. So I'm going from hypotenuse to leg. So hypotenuse to leg. I'm going to write this out. If we look back up here at our diagram, hypotenuse to leg, we're going to divide by square root 2. So I'm going to take my hypotenuse, 7 root 2. I'll just start with x. 7 root 2, and I'm going to divide by root 2, because remember that's what it says over here. Divide by root 2 when you're going from hypotenuse to leg. Root 2 over root 2, or square root 2 or square root 2, ends up being 1, so it cancels out. So you're left with x is 7, which then makes y 7. And again, this problem didn't take very long. Notice how the math didn't change, just the reverse direction, inverse operation. Just so happens sometimes the math or the simplification works out so it doesn't take that long to do. In these two cases, it doesn't take that very much time. But 3 and 4, you'll notice when we do them, it takes a little bit longer because of the rationalization of denominators and some of the multiplication of radicals. So let's look at example 3. They're asking for the two legs. So again, once you find one, you have the other. If I'm going from hypotenuse to leg, go back to my diagram, revisit it. Hypotenuse to leg, it says to divide by square root 2. And you'll notice when I take 11 and divide by square root 2, I now have a radical on my denominator. And for numbers, we like to present them with radicals only in the numerator and not in the denominator. We call this rationalization of denominators. So we're going to take our fraction and we're going to multiply it by square root 2 over square root 2. We're allowed to do this because this is actually just 1. And we chose square root 2 because these two numbers, square root 2 squared, will turn out to be just 2. The denominator will just be 2 in the bottom. On top will be 11 root 2. Double check at this moment that whether or not you can simplify this 11 over 2. It turns out you can't. But let's say, for example, this hypotenuse was 10 and that was 10 over 2. You would simplify that to 5. So whenever you can, simplify, but sometimes, like this case, you can't. So we're going to leave it as 11 root 2 over 2. X is going to be the exact same because it is isosceles. And we only need to do the work once, so I'm just going to copy down the answer for the second leg. So this one took a little bit more time, but again, the math didn't change from example 3 to example 2. It's still going hypotenuse to leg. You're dividing by square root 2. Example 4, they give you a leg and they ask you for the other leg and the hypotenuse. To go from leg to hypotenuse, check your diagram up here. It says to multiply by root 2.